Hi, Hassler here. I'm going to be going through the 12.4 video to introduce keywords that we will see in our quadratic applications. So the picture below shows a basketball player practicing basketball. The path of the ball is traced out by a parabola. Answer the questions that follow. Identify the parts of the parabola that correspond with each question. Okay, so it says, what is the maximum height the basketball reaches? And so when I'm talking about a maximum height, I'm looking at the vertex. And so that vertex is right here. And specifically, I'm looking for the y of the vertex because the y-axis is what is labeled as height. So in order to make that determination, I'm just going to look at the vertex and eyeball across to the y-axis. But I really need to understand what the scale is on this y-axis. So if I look at these tick marks, I have 1, 2, 3, 4, 5 tick marks until I get to 10, which means each tick mark must be worth 2. So 2, 4, 6, 8, 10, 12, 14, 16. So by eyeballing this, it looks like the maximum height that the ball reaches is 15 feet. And I'm going to put the label of feet because that's the label on the y-axis. And so in order to identify what I was looking for, in general, I was looking for the y value of the vertex. The next one says that I need to look at what time does the basketball reach the maximum height. So I'm actually still focused on this vertex, this maximum height part of the graph, but this time I'm going to look at the time that occurs, which means I'm looking at an x answer, okay? And again, I should determine what the scale is. 1, 2, 3, 4. It takes 5 tick marks to get to 10, and so this also must be going by 2s. And so as I trace my eye down to the x-axis, it looks like it took 11 seconds, that's the label on the x-axis, to reach that maximum height. And so time, since that's the x value, means I'm looking at the x value of the vertex because the vertex is related to that maximum height. Okay, C says, at what time does the basketball go through the basket? So again, I have this at what time. And if they're asking me at what time, that means that I'm going to be looking at an x value. All right, going through the basket looks like it's happening right over here. And the x that goes with that, as I trace down, looks like that's happening at 19 seconds. So again, I was asked to find an x value because it said time. And I was asked to find an x value for a particular point. So x value at a given point. Or, they didn't give me the ordered pair, but they specified the location on the graph. D says, at what height does the basketball go through the basket? And so because it's talking about a height, I need to answer my question related to a y value. And specifically a y value at an indicated point or a given point, in this case going through the basket, okay? So again, going through the basket, I circled that, and I'm going to drag that across the, to look at the y-axis. And it looks like the height that it goes through the basket is 10 feet. Okay, so let's take a look at E. E says, how tall is the basketball player? So how tall, again, means that I'm answering as a y value. And I'm going to look at my graph. And the basketball player, it appears, is standing right here. And the top of the basketball player's head is right here at 6 feet. Now that to me looks like it's the y-intercept because he's lined up right on that y-axis, and that's what we call like the initial height or the initial value. That's really right around where that basketball starts to be thrown. And so 6 feet. I'm going to go back here and say the y value is what I was looking for, but specifically, it's the y value of that y-intercept. And remember, y-intercepts occur when x is 0. F says, at what time? So again, I hope you start to notice that these questions are either asking for a time or they're asking for a height. This is, at what time does the basketball reach the ground? And so over here is where it looks like my basketball is reaching the ground, right? And I'm reaching the ground because the height is 0. And so if I count that out, there's 20, 22, 24, 26. I'm right in between, so 25 seconds. And what I'm looking for is the x value of an x-intercept, right? I'm really looking at the x-intercept, and the x-intercept occurs when y is 0, or in this case, when the height is 0. So touching the ground means that, if the ground is represented by the x-axis, I'm looking for an x-intercept. This next one says, at what time does the basketball 12 feet off the ground? Okay, so again, I'm looking for what time, which means I'm looking for an x value. And I was given a y value. I was told what that height was. Okay, so at a height of 12. So here's what I'm going to do. I'm going to go ahead and when the y-axis is 12, I'm going to draw this horizontal line through all the way through 12, a height of 12. And what I notice when I do that is that I go through that height of 12 twice, once on the way up and once on the way down. And so it looks like I hit 12 feet at 5 seconds. And on the way back down, I hit 12 feet at 17 seconds. So it's possible that we have 2 answers because I'm passing through a height of 12 feet twice. It says, how high is the ball at 8 seconds? Okay. So again, they're asking me for a height, and a height means that I'm answering with a y value because that's the label on the y-axis, and I'm given time, which is an x value. Okay. And so if I look back up at my graph, and it says, how high is the ball at 8 seconds? All right, 8 seconds is right here. And so if I trace my eye up, I have the basketball here, and if I trace that over, that was 14 feet. So this was pretty manageable to go through and answer because I had a graph of this picture, and I was able to use the picture to get all my answers. I didn't have to do any calculations. And we did that on purpose because we wanted to make some connections between some key ideas. And so these are key ideas or key words that you need to be looking at when we go to do our application problems. We're often going to be asked for the time that something happens. So for example, the time of a maximum height. And time is related to an x value, right? Anything time related was our x value, and it's the x value of the vertex because a vertex occurs at a maximum. And in order to find the x value of the vertex, we use that x equals negative b over 2a. Remember, that helps us find that axis of symmetry. And so if I were to make this graph, here's my vertex, and I'm looking for that x coordinate of the vertex. I might also be asked to find the what is that maximum height. And if I'm asked to find what is the maximum height, I'm being asked to find the y value of the vertex. And in order to find the y value of the vertex, I need to substitute the x of the vertex into the function. So again, graphically, if this is my vertex, I'm looking for the y component. I'm also going to be asked to find an initial value. Yikes. An initial value or a starting value. And that is being related to the y-intercept. And remember that for y-intercepts, all x values are equal to 0. That's the constant when in that form, y equals ax squared plus bx plus c. I'm going to be asked to find a value